Plastic waste takes hundreds of years to decompose, but scientists have uncovered fungi that can break it down in just a few weeks. Yes, one of the toughest environmental problems we face might finally have a natural solution growing silently under our feet. The discovery. Researchers identified Aspergillus tubigensis, a fungus found at a waste site in Pakistan, that has the remarkable ability to degrade polyurethane, one of the most resistant forms of plastic. Normally, this material would remain in the environment for centuries. But with the action of this fungus, the timeline collapses to mere weeks. This discovery changes the conversation around plastic pollution. Instead of relying only on recycling facilities and industrial interventions, nature itself offers a sustainable tool to tackle plastic waste. How it works. The process is driven by enzymes released by the fungus. These enzymes attack the chemical bonds within plastic, breaking them apart into smaller fragments. Once those bonds are weakened, the fungus consumes the fragments and converts them into harmless compounds. What makes this method revolutionary is that it works directly on the plastic's surface. There's no need for shredding, melting, or pre-treatment. The fungus does the heavy lifting naturally. Scientists refer to this method as mycoremediation, which means using fungi to remediate, or clean up, polluted environments. Beyond one fungus, Aspergillus tubigensis is not the only fungus with this unique gift. Another species, Pestalotiopsis microspora, discovered in the Amazon rainforest, can survive on plastic alone, even in oxygen-free environments. This means it could function in landfills or even in the depths of the ocean, places where traditional cleanup methods are impossible to implement. The resilience of these fungi opens up the possibility of addressing plastic waste across multiple ecosystems, from industrial dumps to marine environments. Why this matters? Plastic pollution is one of the most urgent global crises. Every year, over 350 million tons of plastic are produced, and a significant portion ends up in oceans, rivers, and soil. Microplastics have been found in drinking water, food, and even human blood. The health implications are still being studied, but the environmental damage is undeniable. If fungi can naturally break down plastics, they could become one of the most efficient, cost-effective, and eco-friendly tools in our arsenal. Unlike chemical recycling or incineration, this method does not release harmful byproducts into the air or water. The future of plastic cleanup. Scientists are now working on ways to scale up this natural process. They are experimenting with bioreactors, enzyme sprays, and coatings that could harness the power of these fungi on a large scale. Imagine landfills treated with fungal enzymes that clear plastic waste in months, or ocean cleanup systems boosted by fungi that work even without oxygen. This approach could complement existing recycling and waste management systems, creating a multi-layered defense against the plastic crisis. Still, there are challenges. Researchers must ensure that these fungi do not disrupt ecosystems when introduced outside controlled environments. The goal is to design safe, targeted solutions that harness nature's power without unintended consequences. A natural ally in the fight against pollution. What makes this discovery exciting is not just the speed of decomposition but the hope it brings. For decades, humanity has been searching for sustainable answers to plastic waste, and now a significant part of that solution might be found in fungi that were always here, hidden in plain sight. As more studies confirm their potential, we could be standing at the beginning of a new era, one where biology and technology work together to reverse decades of plastic pollution. Plastic pollution isn't just an environmental issue, it's a human survival issue. While scientists are unlocking powerful natural tools like fungi, we all play a role. Reduce single-use plastics, support sustainable innovation, and spread awareness about breakthroughs like this. The future of our planet may depend on how quickly we act, and nature has already given us a head start. Let's not waste it.